All right, so in this video, I'm going to continue showing you how somebody in the past used this geometric pattern to come up with the designs for the numerals, and that they did so from a base 12 point of view, or a Dozenal point of view. So in base 12 math or Dozenal math, you need 11 symbols to represent the numbers between 1 and a dozen. So you count 1, 2, 3, 4, 5, 6, 7, 8, 9, dec, L, and then do. So do looks like a 10, but it represents a dozen. So L looks like the backwards 3 from what we traditionally look at as the number 3 or the numeral 3 in base 10, but a backwards version. So here you can see a very large version of that numeral. So I'm showing you what geometric pattern they used to come up with the design for that numeral. So all of the numerals are connected to their corresponding circle in this series of circles, and they're done so in such a way that the numeral is touching down on the points that are used to define the position of that circle. When you're drawing this pattern or this series of circles, you need to put your compass on a specific point to get the right distance to draw the radius of each circle. So the radius of these circles is progressing in a pattern of square root of 1, square root of 2, square root of 3, square root of 4, etc. So we're on the 11th circle in the series. It has a square root of 11, or in base 12 that's called L. So the square root of L. So in the last video I showed you how we use the triangle here, the points that are created by this pattern, dividing the length of 1 into half, and then where that line connects with the square root of 3, we were able to create points and draw a line up here, and this gave us the radius of square root of 11. So now what we did is we put our compass on this point here, which has the y value of 2.5, and it's on that's going to be the 120 degree angle. And then we draw a circle with the radius of 3.1. So we can see that it's touching down on that point. And then when it goes across the top here, we add y, 2.5 plus 3.1, and we get 5.6. So the distance from the top of the symbol to the bottom is 2 times 5.6, which is L. So every numeral in the series has the value of the number that it represents incorporated within its design. So that's why that numeral looks the way it does. Someone designed it that way, and all of these numerals have that characteristic when they're drawn on this pattern. So we're going to keep looking at this geometric pattern and ask us, what else is there happening here? What other information are we getting? Why did they choose this pattern to represent that particular number?